Okay, the new syllabus, right? Okay, you are KSSM. Okay, so it's quite different from KBSM. Okay, so I will explain first about how the SPM format. Okay, for physics. Okay, for physics. Okay, so it seems like chemistry. Okay, they got three papers, right? Paper one, paper two, and paper three. Okay, the paper one has 40 questions, okay, of objective. Okay, and paper two, okay, they got three sections, okay, A, B, and C. Okay, for the section A is a structure question. I will give you the example. Okay, how does the structure questions? Okay, and then section B and section C is actually an AC part. Okay, and for section B, okay, for section B, you can choose, right? You can choose whether you want to answer question number 9 or question number 10. Okay, so usually question number 9 is actually from Form 4 syllabus. Okay, and question number 10, okay, it's come from Form 5 syllabus. Okay, and section C, okay, so it maybe come out from Form 4 or Form 5. It means for section C, you cannot choose. Okay, you cannot choose. Okay, and then the total marks for paper 1 is 40 marks. Okay, and then for paper 2 is 100 marks. Okay, so paper 3, okay, starting this year, okay, so there will be no exam for practical, means the written exam. Okay, so mean you have to do a practical in the lab. Okay, they will give you the apparatus. Okay, like three set. Okay, one is for chemistry, bio, and physics. Okay, and they give you like 2 hours. Okay, 2 hours and 15 minutes. So means you have to divide. Okay, on your own. Okay, so how many minutes for how much time that you need for physics, chemistry, and bio. So it's up to you. Okay. So this one I will brief more, okay, later when you come back to school. Okay. So this one for physics 15 marks. Okay. So 15 marks for practical. Okay, for paper 3. Okay. And this one usually on October. So means next year, right? So next year on October. Okay, the real exam for SPM. Okay, so this is the format, right? It's same like chemistry. Okay. Right, and then the next one. So for physics paper 1, what is the example of the question that will be asked? So it's like this. Okay, maybe calculation. Okay, right, and they give you A, B, C, D. Okay, and then another one is like this. Okay, you have to choose A, 1, 2, B, 1, 2, 3. Okay, so this is the new format. Okay, before this in KBSM, they didn't ask like this. They only give you like A, B, C, or D. Okay, but for KSSM, okay, starting this year, they will be use this format. Okay, so that's the difference. Okay, and then for paper 2, okay, so this is the structure question. Okay, section A. Okay, means you have to put your answer in this line here. Okay, right. I think you're already familiar for this one because you're PT3, right? So it's like this too, right? Okay, and then next one is section B. This one is the essay part. Okay, the essay part. Okay, so it means this one you have to answer in the test pad. Okay, so you cannot write the answer in here. Okay, so you will write your answer in the test pad. Okay, and for this one, okay, this is 10 marks. This one you have to choose. Okay, whether you want K, L, M, or N. So this one I will teach how because they got a technique how to answer this question. Okay, and last one, section C. So this is section C. Okay, this one you cannot choose. Okay, and you don't know whether it will come out from Form 4 or Form 5. Okay, before this for KBSM, they got two questions for section C. One is Form 4 and one is Form 5. Okay, so they can choose. Okay, but starting KSSM, this one you cannot choose, and we don't know either whether it's Form 4 or Form 5 will come out. Okay, so that means you have to be good in Form 4 and Form 5 syllabus. Okay. All right. So that's all for the format. Okay, for the physics format. This is actually the experiment. Okay, so this one I will brief later. Okay, when you come back to school. Okay. Alright. So until then, anything you want to ask, whether about the format or anything? Anything you want to ask about the format or anything about the class? Okay. So no question, I think. Yeah. We just started, right? Okay, and then we go to the first chapter. Okay. So the first chapter is about a measurement. Okay, measurement. Okay, so we learn about physical quantities, right? So what is a physical quantities? Okay, so which tastes better, nasi lemak or roti canai? Okay, so this one you cannot measure taste, right? So maybe for you, if the food is good, okay, but maybe for others the food is doesn't taste so good, right? Because it depends on the person, so you cannot measure it. Okay, or can we measure beauty? Okay, so maybe for you that girl is cute, but maybe for your friends the girl is just normal. So that one you cannot measure, right? It's very universal. Okay, so but for the temperature, right? What is the body's temperature? So you can measure the temperature, right? 37 degrees Celsius means you can give the value for the temperature. Okay. All right. So there is thing that can be measured and cannot be measured. Okay. So example that the thing that you can measure is temperature and you cannot measure is taste and beauty. Okay. So the one that you can measure or you can calculate and you can give value to it. Okay. So you call it as a physical quantity. Okay. So physical quantity is a quantity, right? A quantity that can be measured. It means you can put numbers there. Okay, example, if you measure length, so when you measure length using the ruler, okay, let's say 10 cm. So you can give the value to it. So 10 cm is the value. So means length is the physical quantity. Okay, or you can, let's say you measure water, right? The volume of water. Okay, you put in the measuring cylinder. So you, let's say you measure is 100 centimeter cube, right? So means you can give the value to the volume, right? So means the volume is a physical quantity, right? So example here, okay, weight of a book. Okay, so weight is the physical quantity and book is the object, right? And next one is the angle of refraction. Okay, so you measure the angle using the protector. Okay, you got, let's say 35 degrees. So mean you can give the value to the angle of refraction. You can give the numbers, okay, or you can call it as a magnitude. Okay, so angle of refraction is the angle, is the quantity, and the refraction is the phenomenon. Okay, it's the light phenomenon, right? Okay, until then, okay, let's say if you have a question, you can open your mic and just ask, okay? Because I don't open the chat, cannot see, okay? Oh, wait, I can open using the Google Meet. Okay, give me a second.
It's a part that we have a lot of these provisions of materials. Okay, we separate.
Why I'm sorry, I clicked wrongly. Okay, okay, so I can open your, if you can open your mic, right? You can just check me. I use my phone. Okay, so that is a physical quantity, right? So next, okay, so the example here, figure 1.1 shows the example of the measurement involving physical quantities, okay? So state the physical quantities, right? The height of Mount Kinabalu is 4,095. Okay, so what is the physical quantity here? Height of Mount Kinabalu is 4,095. So what is the physical quantity here? Can you give me an answer? What is the physical quantity there? Yes, very good. So height is the physical quantity. Means you measure height. Okay. So here height is the physical quantity. Okay, and then the next one, National Paralympic athlete, right? Muhammad Rizan Kuzi created a world record with record time of 11.87 seconds in the 100 meter sprint event, 3T36 category, okay, in the 2018 ASEAN Para Games. Okay, so what is the physical quantity that we measured here? Time. Okay, very good, right? Time. Okay, time. And also distance, right? 100 meter. Okay, very good. All right, the next one is speed of the tiger, right? Panthera tigris is 49 km per hour to 65 km per hour. So what is the physical quantities here? Speed. Yes, very good. So means you measure speed. So what means here, whatever you measure, so that is called as a physical quantity. Okay. Okay, so this one, let's say I have a sentence like this. So a length of a boat is 20 cm. Okay, so you must know how to differentiate what is the physical quantity, what is the magnitude, and what is the unit. Okay, so length is a physical quantity, right? Because you measure length. So what you measure here? I measure length. So length is a physical quantity. Okay, and 20 here we call it as a magnitude. Okay, we call it as a magnitude and we put it as a in the number form. Okay, in the number form. Okay, and cm is the unit. Okay, so cm is the unit. Okay, so that is first example. So the second one is the speed of car, right? 90 kilometer per hour. Okay, so speed is a physical quantity. Yes, very good. Okay, and then 90 is the magnitude. Okay, and kilometer per hour is actually the unit. Okay, so let's say I have a question, right? One question. So let's say the question state here. State the physical quantity. Okay, physical quantity measured by the thermometer. Thermometer. Okay. So state the physical quantity measured by thermometer. Okay, so temperature. Good. Okay. But if the question asks, state the physical SI unit measured by the thermometer. What's the answer? Kelvin, Celsius, Kelvin. Oh, okay. Some of you answer Kelvin, some of you answer Celsius, right? So the correct answer, temperature is supposedly to be in Kelvin. Okay, so temperature is Kelvin. So you have to remember the difference, right? When you ask you about the physical quantity that be measured or physical SI unit atau SI quantity unit. So you have to difference between those two questions. So what's the questions one? Alright, so this one you have studied base quantity in form 1. Can you identify the base quantity? So can you identify from this one, which one is the 5 base quantity that you learned in form 1? Okay, so can you tell me? Okay, time. Okay, correct. Length. Okay. Say some said density. Okay, density is not a base quantity. Electric current, correct. Okay, electric current. Mass. Okay, mass, right? Okay, another one. Impulse, temperature. Okay, so actually temperature. So this is the 5 base quantity that you learn in form 1. Okay, so I write again here. Okay, so maybe some of you already forgot. So temperature, okay. So the symbol is T, capital letter T, right? And then the SI unit is Kelvin, and the symbol for Kelvin is K. Okay, and then another one is mass, symbol is M, the unit is kilogram, okay, and then the symbol for kilogram is kg, okay, and another one is length, okay, the symbol for length is L like this, okay, and the unit is meter, okay, and the symbol is M, okay. Another one is electric current, okay, the symbol is I, okay, capital letter I. The unit is ampere and the symbol for ampere is A, capital letter A. And the last one is the time, right? So time, the symbol is T, the unit is second, okay, and S. Okay, yeah. Okay, this is actually you learn from for form 1, right? Okay, so when you go to form 4, okay, for physics, we add 2 more. So it will become 7. Okay, so this one. Okay, so before I go to that base quantity, okay, so we learn first, right? The physical quantity, okay, so the physical quantity that can be divided into 2. First one is called as a base quantity. The second one we call it as a derived quantity. Okay, so the base quantity are quantities that cannot be defined in terms of other base quantity. Means this one is the simplest one. You cannot derive it anymore. Okay, so mean the base quantity, the one that we discussed before, 5 base quantity, and after this we will add 2 more. Okay, right? And then the derived quantity is actually one which is obtained by combining base quantity by multiplication, division, or both these operation. Okay, so what does it mean? Okay, so the derived quantity, there we use the base quantity, okay, and then we multiply or divide or both, okay, to form a new unit. So I give you one example. So let's say for force, right? Okay, force, what is the formula? F is equals to MA. Okay, so mass is in kg, right? And then acceleration, the unit is ms negative 2. So you multiply it, okay? And you multiply it and form a new unit. This is called as a derived quantity. Okay, or another example, okay, I give you like velocity, right? Velocity is displacement divided by time. Okay, so displacement is in meter, time is in second. So you got ms negative 1. So see, I use a division to form another unit, and this one I use a multiplication to form another unit. Okay, and this one I got from where? Meter and second. I use the base quantity, right? And then I divide them, or I multiply them, or I use multiplication and division at the same time. I form a new unit. Okay, is it okay? Can you understand? Right? Okay. Alright, so next we goes to the base quantity. Alright, so some of you already said for luminous intensity. And what is the luminous intensity? It's like a light intensity. Okay, and the unit should be in candela. Alright, and another one we add is the amount of substance N. Okay, we call it, and the unit is mole. Okay, this one is, we use it in the chemistry, right? Okay, so this we add another 2. So this 5 you already learned in form 1, okay, until temperature. And these 2 we add when you learn physics form 4. So means the total base quantity that you need to remember is 7. Okay, so this one you have to remember. Okay, so 7 base quantity. Okay, so this is the measuring instrument that we use, okay, to measure each of the base quantity. Okay, so this one is actually an example, right? How you form the derived quantity. Okay. So let's say I have a book. Okay. So let's say the book here, the length is 30 cm and the width is 22 cm. Okay. So if I want to, I just multiply if I want to buy air to find area, right? So I got 660 cm squared. So this, sorry, 660 cm square. So this also we call it as a derived unit. Okay. Okay, or let's say if I have a rectangle here. So this is 5 meter, this is a 5 meter. So if I want to find the area, 5 meter times 5 meter, right? So you got 25 meters square. So even it's only consists one unit that is meter, but since you perform a multiplication to it, so it's still considered as a derived unit, even it only consists one unit. Okay, but since you perform multiplication on it, it's still considered as a derived unit. Okay. Okay, so a derived unit is related to the base quantity through a formula. I mean, I already told you before, derived unit, they use a base quantity, right? And then they divide, multiply, or using both divide, division, or multiplication, then they form a new unit. So that new unit, we call it as a derived unit. Okay, so let's say the first one, okay, because I noticed some of you, they put density as a base quantity. Okay, so density is mass divided by volume. Okay, so mass is in kg, volume is a meter cube. Okay, so what is the unit here? Kg m negative 3. So you can see you perform the division, right? So when you perform a division, so this one we call it as a derived unit. Okay, so this one we call it as a derived unit. Okay. Alright, so this one you have to determine the derived unit for the following derived quantities. So let's say we try the first one. Okay. So length is in meter. Okay, the unit is in meter. Width also the unit is in meter. So meter times meter, you got meter square. So this is the derived unit for area. Okay. So can I let you try first for number 2 and number 3? For number 2 and number 3, I give you like 2 minutes, okay, for you to try. Okay, for number 3, actually I already explained before. M power of 3, yes, very good. M power of 3, kg, M power of negative 3. Alright, very good, okay. So, length is in meter, width also in meter, height also in meter, so you will get meter cube. Okay, right? And then for number 3, we done this before. Mass is in kg, volume is meter cube. Okay, so then the answer should be kg m negative 3. Okay, so very good. Alright, so how about number 4 and number 5? Okay, can you try first for number 4 and number 5? They already give you the formula there. Okay, you just find what is the unit for displacement and what is the unit for time. ms negative 1, kg, ms negative 1. Wow, very good. Okay, good, right? So for the displacement, the unit is meter and the time is in second. So if I change it, it should be ms negative 1. Okay, how about the momentum? So momentum is mass multiplied by velocity. So the mass is in kg. Alright, velocity already calculate, right? So number 4. So we just copy down the answer. Should be kgms negative 1. Okay, very good. All right, for number 6 and number 7. Number 6 and number 7. ms negative 2. Okay. kgms negative 2. Right, very good. Okay, correct. Okay. So for the acceleration, okay, so actually what is the formula for acceleration? A is equals to V minus U divided by T, correct? Final velocity minus initial velocity you divide by time. Okay, because final velocity and initial velocity, they got the same unit, that is ms negative 1. So we only take one. Okay, so ms negative 1 and the time is in second. Okay, so and then you try, okay, to solve it. So you got ms negative 2. Okay. Okay, what about the force? Right? Force is actually mass multiplied by acceleration. So the mass is in kg, acceleration is ms negative 2. Okay, so you got kg ms negative 2. Okay, or we call it as a Newton. Okay, short form is a Newton. Newton is actually kg ms negative 2. Okay, next, how about the pressure? Okay, so pressure is this one we already calculate the unit there. kg, ms, and m negative 2. Okay, correct. Okay, kg, ms negative 2. Okay, and then the area is m power of 2. Okay, so this one I can put it. Okay, so it will become kgs negative 2, m negative 1. kgs negative 2. Okay, or we call it as a Pascal. Okay, Pascal. Or you can put like this, because we already know kg ms negative 2 is actually Newton, right? Newton, and the area is m power of 2. So nm negative 2. So this 3 is the correct unit for pressure. Okay, are you clear? Anything you want to ask? Clear, right, very good. If anything you want to ask, just put the questions in the chat. Teacher, can you explain again what number? I will explain to it. Okay. Okay, how about number 9? Okay, number 9. Okay, can you try to do first? Number 9 and number 10. And number 9, number 10 actually we already learned in form 3, I think. Work or also power. kg and power of 2s negative 2. Correct? Or we can call it as what? Newton meter. Also correct? Yes. Can call it as a joule. Right? Work is in joule, energy also in joule. Good. Alright, so how you got the answer? So force is kg ms negative 2. Okay, and then the displacement is in meter. So kg m square s negative 2. Okay, so this is 1. Okay, 1 unit, or another one. Okay, force is in Newton, right? Okay, and then displacement is in meter. So we can put it Newton meter. Also correct, right? Okay, and then another one, we call it as a joule, or the short form is T. Okay, some of you already answered number 10. Okay, good. So both of it correct. Okay. Alright, for number 10, okay, for number 10, we use kg m square s negative 2 and the time is in seconds. I can write this one, so it becomes kg m square s negative 1. Okay, or you can put Newton meter over second also can, or we can put it as watt. The symbol is W. Wait, s negative 1 we go kg m square s negative 1 divided by s should be kg, sorry, negative. Wait, this is index, right? Divide is negative. Yeah, negative 3. Sorry. Okay, should be negative 3. Kg m square s negative 3. Okay, this is divide. So when divide, the index should be minus, right? So negative 2 minus 1, so you got negative 3. Okay, very good. So the answer should be kg m square s negative 3. Okay, next one. So this one I let you answer first. Okay, so this is the example of question. F is equals to kx. Okay, this one is Hooke's law. Okay, Hooke's law. Okay, what is the unit for K? Spring constant K. If you the extension of the elastic spring is directly proportional to the stretching force acting on it. Okay, so it can be shown by the following formula. F is equals to Kx, where F is the force, the unit is N, K is the spring constant, X is the extension, the unit is in meter. K is the acceleration. No, K is the spring constant. It's actually the stiffness of the spring. Okay, I think you already learned this one, right? I cannot remember. Maybe commented. Can anyone get the answer? K is kg m negative 1 s negative 2. Okay. Any other answer? Let's see whether it's wrong or correct. Nm negative 1. Okay. Anyone else? Anyone else want to try? Okay. So when they ask you to find the unit for K, right? So you make K as the subject. Okay, I think I did learn this one. Okay, algebraic formula, right? Okay, so K is F over X. Okay, so this one I change to this side, so it will become divide. So K is F over X. Okay, what is the F unit? Is in Newton. Okay, since they already give you the unit, so you have to use the unit that been given. Okay, I know N is kg, M negative 1, M is negative 2, right? Okay, but since they already give you the unit in the question, so use the unit that question give. Okay, so F is Newton, X is meter. So you got Nm negative 1. Hmm. Okay, is it okay, Joey? Yes, okay. So we do a revision, right? A little revision from Form 1. Okay. So this is called as a prefix. Okay. So this one, the prefix, you have to remember the value of each prefix. Okay. So tera, giga, mega, kilo, hecto, deca, deci, centi, milli, micro, nano, pico. Okay. So this one you have to remember. Okay. What is the value for tera? 10 power of 12. Okay. Because when you need to convert the unit, okay, let's say they give you in kilometer, then you need to change to meter. So this one you need to know. Okay. Or let's say change from centi to meter, centimeter to meter, right? So you have to know what's the value of centi. So centi is power of negative 2. So later you have to multiply by power of negative 10 power of negative 2 to get the answer. So I give you one example. Okay. So let's say the question said 50 cm square change to meter square. Okay, so what you have to do? Okay, 50. Okay, so C is actually here the symbol is centi. So what is the value here? 10 power of negative 2. Okay, but you can see here, okay, so this one is a square, right? So means the prefix also you have to square the prefix. So you got 50 times 10 power of negative 4. Okay, and then you change to the standard form. Okay, so this is 1, right? So 5 times 10 power of 1, 10 power of negative 4. So you got 5 times 10 power of negative 3. Okay, so this is the example. Okay, how to change, okay, by using the prefix. Right, this is especially important. Yes. Okay, and then the next one. Okay, this one you have to know how to change to the standard form. Okay, so let's say if I have 33,000. Okay, and then I have to change to the standard form. 1, 2, 3, 4. Right, so 3.3 times 10 power of 4. Okay, so if I have 0.0007. Okay, change to standard form. Okay, 1, 2, 3, 4. Okay, so 7 example. Okay, how you want to convert to standard form. Okay, right. The next one is the Vernier Calipers. Okay, this one also you learn in Form 1. Okay, so Vernier Calipers without zero error. It means, okay, if you push the vernier scale forward, you push it until here, the zero will be in one line with the zero at the vernier scale. Okay, the zero from main scale should be one straight line, okay, to the vernier scale. Okay, alright. So how you want to read the vernier calipers? Okay, so the first one I draw here. Okay, this is zero. You put a mark. Okay, put a mark line, okay, at the zero for the vernier scale there. Okay, and then after that you read the main scale first. Okay, so 1.1. Okay, and then after that you read from the vernier scale. Okay, so you have to find, okay, that one straight line that can be formed from the main scale and vernier scale. So let's find one straight line. Here, right? Mm, here. Okay. Okay, so for this one, 6.5. Okay, so you add by 0.065. Okay, so this one is 5611 cm. Okay, so they got actually for vernier calipers is a two decimal point only. Okay, but for this one, this is special one because they got a scale between two vernier scale. 1 and 1.5. Usually they only got 1, 2, 3, 4, 5, 6, 7. They don't get 1.5, 2.5, no. Okay, but for this one, it's a special one, so 1.165. But usually in your syllabus, okay, for vernier calipers is only 2 decimal point. Okay, vernier calipers is 2 decimal point. Okay, and the units must be in cm. Okay, so let's see this one. So what if the vernier calipers with the negative zero error? So how do you know that whether it's a negative or positive? You have to see zero here on this part. If the zero is on the left, okay, on the left side of the zero for main scale, okay, and on the left side, so this one should be negative. Okay, this one should be negative. Okay, so negative, okay, and then you have to find which can form the straight line. So this one, right? Okay, so you have to read 1, 2, 3, 4, 5, 6. Okay, so negative 0.06. Okay, but for vernier calipers with negative zero error you cannot take directly negative 0.06. Okay, you have to minus first with minus first with 0.06. So 0.04 is actually the negative zero error. So you put the sign of negative here. Okay, you put the sign of negative there. Okay, alright. So first you read the zero error first. Okay, and then you measure the object. Okay, so when you measure the object, okay, so this let's say this is the object measurement. Okay, so this one 3, 3.1, 3.2, 3.3. Okay, so 3.3, and then find one line that can form straight line between main scale and vernier scale. So here as you can see, okay, so 1, 2, 3, 4. So plus 0.04. Okay, so the answer you got 3.34. Okay, but this one is not the correct measurement because the vernier calipers has zero error. So if you want to find the correct reading, you have to minus first. Okay, sorry. Correct reading. Okay, you have to minus first 3.34 minus negative 0.04. Okay, so this one already know negative, negative become positive. So plus 0.04, you got 3.38 cm. So this is the correct reading. Okay. Until then, anything you want to ask? If you're not clear, anything not clear that you want to ask, especially because this one is actually for KBSM, they put in a Form 4 syllabus, that's for form, and then they change to Form 1. So I'm afraid maybe you already forgot how to read the vernier calipers. Anything you want to ask teacher for vernier calipers? No question, right? Okay, so what about the positive zero error? Okay, so you can see the difference here. Okay, you can see the zero for the vernier should be positive. Okay, so positive, then we find one straight line here, right? So 1, 2, 3, 4. Okay, so positive 0.04. Okay, so should I minus with 0.1? No need. Okay, only for the negative zero error for vernier calipers that you need to minus with 0.1. Okay, but for this one, use it, okay, as a zero error. Okay, and then this one, okay, so 3.1, 3.2, 3.3. Okay, so 3.3, and then this one is 0.04. So 3.34. Okay, so how to find the correct reading? Minus, right? So 3.34 minus with the zero error. Positive 0.04. We got 3.30 cm. Okay, 3.30 cm. Okay, for this one, I want to see whether you can still read and still know how to read micrometer screw gauge. Can you try first? Or micrometer screw gauge. Try first. Hmm. Can you still remember or not? Because let's say in paper 3, right, the experiment part, let's say they give you, okay, how to measure the diameter, okay, and then they give you the vernier calipers or micrometer screw gauge, and then you don't know how to read, will be hard for you later. So you have to know because we don't know what will come up in the practical. So what measuring tool that we need to use. So you have to know, okay, how to measure. 2.88. Okay, 2.88. Okay, let's see whether it's correct or not. Okay, so this is 0, 0.5, 1, 1.5, 2, 2.5. So 2.5. Okay, and then see the line here. Okay, so you read from 35, 36, 37, 38. So plus 0.38. So you got 2.88. Okay, so must put the unit. So the answer should be 2.88 millimeter. So if they ask you which one is more sensitive, vernier calipers or micrometer screw gauge, so what is the answer? They say the question give you a choice if to choose. Okay, they give you a picture of vernier calipers, they give you a picture of the micrometer screw gauge, and then they ask you to choose which one is more sensitive. Yes, very good. Micrometer screw gauge. Okay. So let's say they ask you why, the reason. Okay, because the scale, okay, the scale for the micrometer screw gauge is smaller. Okay, they can measure until 0.01 mm. Okay, and then before I forgot, okay, for physics, the unit is very important. Okay, let's say when you calculate something, and then make sure you put the unit. Okay, because for physics units is very 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 important. Okay, okay, so let's see for this one. Okay, for this one, can you try first? Hmm. This one is positive zero error, so how does you know? Okay, how can you know that this one is positive, this one is negative? For vernier calipers, we see whether it's on the right, on the left, right? Okay, but for the micrometer screw gauge, we see whether it's at above or below part. Okay, so for this one, it's at the above, right? So means it should be positive. Okay, so what is the zero error here? This one, before you put the object, you have to see first whether the micrometer screw gauge got zero error or not. Positive 0.01. Yes, very good. Okay, then this one, the reading is 1.76. Yes, very good. So 1.76. So you want to find the correct reading. 1.76 minus positive 0.01. So you will get 1.75 mm. Okay, so this one is a positive zero error. Okay, what about the negative zero error? So this one is negative. Okay? This one is negative zero error. Okay, so the negative you can see, right? The zero here is at the below part, right? So means this one is should be negative. So negative what? Negative 0.03. Okay, good. Okay, don't read from 45, okay? You have to read from 0. So negative 0.03. Good. And then later we put an object, we measure the object. So what is the measurement for the object here? 6.1, 6.16. Are you sure? 6.16? You can 6.66. Okay. So 6.5 plus, okay, this is 15, this is 16, right? So 0.16 should be 6.66 mm. Okay, and then you have to find the correct reading. So 6.66 minus with negative 0.03. So you will get 6.69 mm. Okay, so that is for positive and negative zero error. Okay, so until then, do you have any question? So this one we continue next week. Are you clear how what is the base quantity? What is the derived quantity? Okay, remember base quantity is the 7 quantities. Okay, that one is the base quantity. You cannot derive anymore. But for derived unit, means you have to use the base quantity, the base unit. Okay, and then you have to use a multiplication or division or both, right? To find to form another new unit. That one is a derived. Okay, so I will stop until here. Okay, so we continue next week. Okay, so thank you class. Okay, have a nice day. Have a nice weekend. Bye bye. For the please send the attendance to me. Okay. You're welcome. Bye. Welcome. Thank you for joining my class. See you next week.